Hello and welcome to the channel. So in today's video I want to make a ball turning attachment for the lathe. Now I've never used a ball turner, let alone make one, but I think the basic idea and operation of them is relatively simple. So I'm going to be attaching it to the lathe using the T-slots on the cross slide, and I'll probably start by taking a few measurements just to see what size steel I need, and then we'll go over to the Bridgeport and we'll start cutting some metal down. So I'll start by using a bit of scrap 10mm steel that I've got, and I've also got this roughing mill. It's a 12mm roughing mill, but as you can see the end of it's completely smashed apart, but it still works for side cutting relatively well. Okay, so I've got another 2 bits of scrap steel here that just need squaring up, and essentially these are going to become the sides of the ball turner. Now I do end up going back and turning these down a bit further later on in the video because I changed the design to a bit of a less complicated design, let's say. you can see here, I'm going to switch over to a 45-degree router bit. Now, these router bits were actually only intended for wood, but I realised that they are brazed carbide, so technically it should work for metal as well. And to my surprise, they actually work amazingly well for metal, to say that they're only made for wood. As you can see here, I've got two of these metal base plates and these two sides. Essentially what I'm doing here is forming a bit of a metal box. This metal box is what the ball turner is going to sit on, and it's also what's going to house the bearings. Now you can see at the minute, there's a bit of a gap in the middle, about a 3mm gap, which eventually I will get rid of. And these are the two bearings that I've got. These are the two bearings from the tailstock support video. They're the only bearings I'd lying around, but one will go in the bottom and one will go in the top. So I've just trimmed those two sides down, which has removed that gap, as you can see. All I'm going to do now is try and square it up as best as I can with a 1, 2, 3 block on both sides, and then I'm just going to weld it together. So this is a bit of 15mm scrap plate steel that I've got lying around, and I'll be using this and a giant 114mm hole saw that I've got to cut out a nice lovely round bit of steel. This is going to save me a lot of time. This bit of steel in turn is going to be used for the turning part of the ball turner, if that makes any sense. So I'm just going to chuck this into the lathe and clean it up a little bit. I'll probably start by facing one side and then turning the outside diameter down, flipping the part and doing the same thing. And then I'm going to bore a hole in the centre, which is going to coincide with the next part. Okay, so this is the next part then, and this is actually the head off of a giant bolt. And when it's finished, it should screw perfectly into the centre of that previous plate you've seen us cut out. Okay, so those two parts are finished now, and to screw these together, I actually had to put the disc into the oven and put the post in the middle into the freezer, and this actually helped massively to screw them together. So this is another brazed carbide router bit, but this one's for creating dovetails, and I do believe it's around 14 or 15 degrees. So these two plates that you see here will eventually become the dovetail. Now the reason that I'm starting with two plates and not one is because I kind of took the hard path really. What I essentially need is a dovetail with a thread going down one corner, and you'll sort of see why a bit later on. But for now, I'm going to clean up both of these plates together in the vise, drill down the centre and then tap it. Once I've done that, I can sort of separate the plates, lay them flat in the vise and bring in the end mill just to trim it up. And you'll sort of see how all this comes together a bit later on. So this is that bit of 15mm plate steel that we cut the disc out of earlier on. And I've just chopped the end up into a couple of different pieces, and I do take 2 here, but I actually only need 1. And this bit of steel that you see here will eventually become the insert holder, and this is what's going to hold the carbide insert and do all the cutting. So these series of holes that you can see me drilling here are actually going to be for a locking mechanism. And to make that, I'm going to use this bit of steel bar that I've got here. I'll first start off by making a bit of a pin, which will slot into the bottom, and then making a bit of a cam mechanism which will actuate the pin up and down. join these two pieces together, I'm going to give it a good hit with the hammer. This will belly the top over and make sure these two never come back apart again. Now the dovetail's finished, I can start working the screw. This is what's going to engage with the corner of the dovetail and slide it in and out for making various size balls. This is just a bit of 3mm plate steel that I've cut a slither off one side. I'm going to chuck it into the vise and cut it down to size and then clean it up. So once I've done that, I'm going to cut a bit of an L-shaped slot in it, and this is going to act as a bit of a retaining plate for the screw to stop it from winding in and out. So I've changed the jaws on the chuck to clamp on the outside of the part, and that's just going to give me a little bit of extra rigidity when I'm milling. This is the indexing head, and I've put it in this just to get a nice 45-degree angle and drill a hole, and this is going to be for the handle. So now that I've got the majority of these parts made, I can put this base plate back into the mill, line everything up with the dial indicator, and then drill 4 holes into it, and these 4 holes will allow the bolts to go through and screw into the T-slots below. This is a bit of 10mm steel, and it's the same width as the base plate for the ball turner, and I'll be using this to make the T-nuts. This is a bit of 6mm plate steel, and I'm going to use this bimetal hole saw just to cut out a small little disc. I'm going to then chuck it up into the lathe, clean it up, bore out the centre and then thread it, and that's going to screw onto the back of the base plate. So at this point in the project, I'd actually realised I made a bit of a mistake. I made a bit of an oversight because I had originally thought that the hole in the centre of the inserts was 3mm and that the threads thereby would be 3mm. But that's actually not true. It turns out that the screws are 2.5mm and the holes in the centre of the inserts are 2.8mm. The piece that I made earlier in order to hold the insert was actually wrong, this piece here. And I want to remake it, and I also want to change the tool geometry as well just a little bit so it suits the style of cutting just a little bit better. So I've made another one here, and I brought a few different little tools. I brought a 2mm collet so I can hold a 2mm drill bit. I got some 2.5mm taps and some M2.5mm torque bits which will actually screw the inserts down. I also got myself an extra 3mm end mill because I accidentally snapped my other one on the side of the vise. So this is the sort of new pocket design that I'm looking at for this insert. It's a lot more suited to this insert and it should give me a lot more clearance on the left hand side for making more of a diameter on the ball. Okay, so now the ball turner is fully complete and been assembled, I need to make a bit of an arbor. This is what the balls are going to screw onto for me to be able to turn them down. Okay then, so I think that draws an end to this video. It was quite interesting, learnt quite a lot. It was something a bit different. I never used a ball turner before, or made one, so it's first time for everything, I guess. I'm very happy with the project because it works. I'm very happy with the end result. So, yeah, thank you for watching, and I'll see you in the next one.